Here is question number 11. Two stones, A and B, are whirled in different horizontal circular paths. Stone A is 3 times heavier than B, moving in a radius twice as that of radius of B and with speed 1/3 as that of speed of B stone. The ratio of their centripetal forces acting on A and B will be what? Now, according to the data given in the question, let's say, suppose mass of stone A is 3m. Then mass of stone B we can write m. Radius of circular motion of stone A is supposed 2r. Then the radius of circular motion for stone B will be just r. Suppose the speed of stone A is v, then according to question, speed of stone B will be 3 times v. Now expression for the centripetal force for stone A will be what? mv square by r. We know very well mass is 3m, speed is just v, so v square divided by radius ra, that is 2r. Similarly, expression for centripetal force for the stone B will be what? Mass is just m, speed is 3v, so 3v whole square divided by radius of brb, that is r. That is equation number 2. We have to take the ratios. Let's take the ratio. Fa upon Fb. We may write 3mv square divided by 2r multiplied by r divided by 9mv square. mv square cancel, r and r cancel, 3 3 are 9, and after solving we can get Fa and Fb ratio is 1:6. So after looking the options, we can say that option number 3 is absolutely correct. So that's why we will go with option number 3 only. Now let us proceed to the next question, that is question number 12. Here is question number 12. 3 blocks of masses 3 kg, 5 kg and 4 kg are connected with massless string is moving downward with the help of force F with constant velocity shown in figure. The tension T in the string connecting 3 kg and 5 kg blocks will be what? Means you have to calculate the tension T, this one, between 3 and 5 kg. Object is moving with constant velocity. We can say that acceleration of the system is what? 0, and therefore net force acting on the system is what? 0. If there is no acceleration, then there must be no forces, or there must be net balance forces. So with help of this concept, we can get the net upward must be equal to net downward. That's why total upward force, that is F, must be equal to the total weight of the system, that is 3g, 5g plus 4g. 3g plus 5g plus 4g, where g is acceleration due to gravity. After putting the value of g as 10, we can get the value of force F given in the diagram as 120 Newton. Now let's draw the free body diagram for 3 kg block. So for 3 kg block, we can write the forces acting on it is tension T downward, its weight 30 Newton downward, and an applied force F upward. And since it is moving with constant speed, therefore acceleration of it will be 0. There means the no net resultant force is acting. So we can say that the upward force must be equal to the total downward force, that is T plus 30. As a result, we can get T equals F minus 30. F is 120, and if we put the value of F here, we can get the tension T value as 90 Newton. So after looking, we can say that option number 2 is absolutely correct. So that's why we will go with option number 2. Now let us proceed to the next question, that is question number 13. So here is question number 13. A container containing ice at 0 degree centigrade and having outside surface area of 1.6 meter square and thickness 1 centimeter is placed in a boiling water. If 2 kg of ice melts in 30 minutes, then the thermal conductivity of material of the container will be what, given that the latent heat of fusion of ice is 3.36 into 10 to the power 5 joule per kg. Now we know the amount of heat required to change the state of ice. We can write delta Q, that is m times latent heat of fusion. So from here we will get delta Q as m2 into LF, that is given in the question, 3.36 into 10 to the power 5 joule. Now we know very well, according to law of heat transfer, according to law of heat transfer, we have rate of flow of heat, that is delta theta upon delta T equals K times capital A upon L into delta T, where K is the thermal conductivity of the material, A is area, L is length, delta T is temperature difference. Now plugging the values, we will get delta theta, which we have calculated, 2 into 3.36 into 10 to the power 5 divided by the time taken in this process is 30 minutes. Let's convert it in seconds. That will be 30 into 60 equals K. We have to calculate. Area is given 1.6 divided by 1 centimeter is thickness, or you can say length. Let's write it in meters. So 10 power minus 2 multiplied by the temperature difference, that is 100 here in this case. So after solving the above equation, we will get the value of K as 0.02 watt per meter per degree centigrade. Now if we look for the options, we can say that option number 4 is absolutely correct. So that's why we'll go with option number 4. Here is question number 14. A Carnot engine used as refrigerator absorbs 380 joule energy in one cycle from low temperature reservoir. If efficiency of Carnot engine is given 5%, then what will be the amount of work done on refrigerator per cycle? Now here the Carnot engine is used as a refrigerator. Suppose total heat supplied is QH, and out of this QH, W is involved in work done. Then the amount of heat absorbed by the refrigerator will be what? The rest part, suppose it is QL, heat left. So we can write the total heat given, that is input, and output is work done. So here it is output. We can write total heat supplied is QH, out of which W involved in work done, and rest is QL. So we can write the efficiency N equals output upon input. Output is W, input is QH. Efficiency given 5%, that is 5 by 100 equals W upon QH is what? W plus QL. So QL plus W. Else you can write QL is given 380 joule is absorbed. So that's why putting the values of QL, 5 by 100 equals W upon 380 plus W. And after solving for W, we can get W, that is work done, will be 20 joule. So after looking at the options, we can say that option number 2 is absolutely correct. So that's why we'll go with option number 2. Now let us proceed to the next question, that is question number 15. So here is question number 15. The power radiated by black body is capital P at a certain temperature. If the power radiated by this body becomes 1 by 16th times, then the wavelength corresponding to maximum intensity becomes what? Now, this question is combined applications of Wien's law as well as Stephen's law. Wien's law states that the wavelength of maximum intensity of emission of black body radiation is inversely proportional to absolute temperature. Lambda is inversely proportional to absolute temperature. And the According to Stephen's law, the power radiated will be directly proportional to absolute temperature to the power 4. Now if the power radiated is 1 by 16th times, then we can say that absolute temperature reduced to half. And if absolute temperature reduced to half, then according to this equation number 1, we can say that the wavelength will be increased by 2 times. So we can say that this question is combined applications of Wien's law as well as Stephen's law. So that's why we will go with option number 1. Here, if P reduces to 1 by 16th time, then absolute temperature becomes half, and therefore wavelength lambda will be twice. So after looking to the option, we can say that option number 1 is absolutely correct. So we will go with option number 1. Now let us proceed to the next question, that is question number 16.